Today we are going on to section 17.2, and that is area between a curve and an axis. Okay, first of all, we'll look at the area of a region above the x-axis. That means this area. In order to find this shaded area, we have to integrate from a to b this function here, x, y in terms of x. We put it here, fx and dx. I will illustrate this with examples. Okay, now let's take a look at example 5. Okay, example 5 says that diagram shows part of the curve. Find the area of region A. Now, if I want to find the area of region A, I will integrate from 2 to 3. Okay, this one, 5 over x squared dx. So I do the integration. I take out 5. I do the integration as per normal. 3, 2, I sub in, I manipulate, then I will get a 5 over 6 unit square. This will be the region A. Alright, next, find the value of k such that the area of region B is equal to the area of region A. Now, in order to find the area of B, I need to integrate from 3 to k. 3 to k, this particular function, it must be equals to 5 over 6 because these two has the same area. Therefore, I integrate, I substitute in, I will solve, and therefore I will get your k as equals to 6. Alright, so this will complete your example 5. That means if we want to find the area under the curve here from A to B, we just need to integrate this, okay, with respect to x, and then we can get the answer for the area under the curve. Okay, now next we move on. Now let's take a look at example 6. Okay, example 6 says that this is the graph of y equals to 1 minus x squared. The region bounded by the curve and the x-axis is a semicircle. They tell you this is a semicircle. Okay, now explain what, when we integrate 0 to 1 of this function represents. Now you will see that if I integrate from 0 to 1, is actually this area. So when I integrate this, it represents the area of the quadrant. This is a quadrant because it's 1/4 of a circle of radius 1 unit. So this is how you explain part 1. Now part 2, hence or otherwise, find the value of this. Now we will use the hence because we know that it's a quadrant. When we integrate 0 to 1, it's just 1/4 times the area of a circle. This is area of a circle, and this circle has radius 1. So we just substitute in, we will get a pi over 4. Excuse me. Alright, so that will complete our example 6. Okay, now next, let's move on to example 7. Now example 7 is this. The question says, this is the diagram, shows the line x equals to k, alright, and part of the curve y equals to e to x. Find in terms of k the area of the shaded region bounded by the curve y equals to k, the x-axis and the y-axis. Actually, it just means the shaded region here. Now, in order to find the shaded region here, we integrate from 0 to k, y equals to this, so we put e2x here, dx, and I integrate. So when I integrate, I get this answer. I plug in k, I plug in 0, I will get this answer for part 1. Now part 2, given that the area of the shaded region is 10 square units, find the value of k correct to 3 significant figure. We know that this is 10, so we manipulate, we take ln on both sides, and we calculate the answer. It will be a 1.52 corrected to 3 significant figures. Alright, that will be your example 7. So what am I trying to say here? The area under the curve, okay, bounded by the x-axis and 2 lines, will be y equals to something. That something here you put here and you integrate from here to here. You will get the area under the curve. Alright, okay, let's move on to example 8. Okay, Example 8 is a trigo question. Alright, the diagram shows part of the curve y equals to 2 plus 4 cosine 2x meeting the x-axis and at the points P and Q. Show that the x-coordinate of P is pi over 3 and find the x-coordinate of Q. Now at the x-axis, y is 0. So I will put this equal to 0. I will do for trigo solving the basic angle and so on. So basic angle is pi over 3, and because cosine is negative, is at the S and T quadrant, I will get x pi over 3 and 2 pi over 3. Now because P is nearer to the origin, this will take the smaller value and Q will take the bigger value. So the x-coordinate of P is pi over 3, while the x-coordinate of Q is 2 pi over 3. Now next, the question asks for find in terms of pi the area of the shaded region. Okay, now the area of the shaded region will be, I integrate from 0 to P, O to P. That means it's from 0, P is pi over 3. So this one, the x-coordinate is pi over 3. So I integrate from 0 to pi over 3, this particular function, dx. So I integrate accordingly, I sub in accordingly, and when I press the calculator and manipulate, I will get the answer as this particular answer. Because the question wants it in terms of pi, okay, this will be the final answer given, the exact answer to part 2. Alright, so this is for example 8. Now let's move on. Now what if the area of the region is below the x-axis? What will we do? Now if the area is below and I integrate from A to B, it will give me a negative answer. Now we know that area is always positive. So what we do is that we add a negative in front. So if a curve y equals fx is below the x-axis over the interval A to B, then the area A bounded by the curve, that means this area A, the x-axis and the lines xa and xb is given by A equals to negative of this. Now because this particular value is negative, so we take negative of it, we are making it positive. Therefore we can find the area under the curve that is bounded by the curve and the x-axis, that is below the x-axis. Okay, now let me illustrate with example 9. Now let's take a look at example 9. Okay, example 9 says that the diagram shows part of the curve. This is part of the curve, this particular equation. Okay, the x-coordinate of the point P is 3/4. Point P is 3/4, so I put 3/4 here. And the x-coordinate of point Q is -2. Okay, find the total area of the shaded region bounded by the curve, the x-axis, and the lines from P and Q perpendicular to the x-axis. Now, in order to find the region A, I integrate from -2 to 0. I'll integrate this from -2 to 0. -2 to 0. So I'll get this answer. I manipulate. I will get this as the answer, 28/3. Now in order to get this particular region here is below the x-axis, therefore for region B I will have to put negative of this. Okay, I manipulate, I'll get 171/256. So when I add region A and region B together, I will get a 10.0 unit square. I will get a 10.0 unit square. Now, some people will be asking me, why is it that I cannot integrate from this -2 to 3/4? I can just integrate from here to here and get the answer. Now, the answer is no. Let me illustrate to you. Okay, all of you look at this particular page here. Okay, alright, I better draw it the same way, so let me just draw it again. Alright, So this is the particular question. Now, let's say this is 4 unit square, alright, the area, and this is, let's say, 3 unit square, the area. Now, if I integrate from a to 0, I will give 4 unit square. If I integrate from 0 to b, it's actually a negative value. So if I take continuously from a to b, the answer will be just 1 unit square, where I have 4 minus 3. Okay, now this is wrong because we want the total area. We want this 4 unit plus 3 units. Okay, so we must integrate from 0 to a, and then we integrate from 0 to b. Sorry, my mistake. Let me repeat this again. We must integrate from a to 0 to get this region, plus we integrate from 0 to b to get this region. Then we'll get the total area. We cannot integrate from a to b because this is positive, this will be negative. In the end, we will not get the correct answer. Okay, so be very mindful that we must take them individually and not combine them together, because this total area is 7. From here to here is 4. From here to here is 3. Alright, if we take continuously, it will be positive and negative. We will only get 1 unit square, which is wrong. Okay, we will only get 1 unit square, which is wrong. Okay, so please take note of that. Okay, so that will be your example 9. Next, we move on to example 10, or area of a region between a curve and the y-axis. Now it's this way, this is the area bounded. Now I need to warn you, if you are taking with respect to the y-axis, you have to write x in terms of y. Okay, the function must be x in terms of y. The area A bounded by the curve x equals to gy, the y-axis and the lines C and D on this positive side, and C less than D is given by, you integrate C to D with x written in terms of y, the y expression dy. Okay, now I will explain with an example. Now let's take a look at example 10. Okay, let's take a look at example 10. Now I want to find the area, okay, that is shaded. That means I'm integrating from 1 to 9, and I'm with respect to the y-axis. Now the equation is given in terms of y equals to something. So this is not possible. I must put x in terms of something. Okay, can you see here, x in terms of y? Okay, so I have to rewrite. Okay, x equals to plus minus square root y over 9. Now since x is bigger equal to 0 according to question, I can only take the positive value. So y over 9 is actually y power half over 3. So x is 1/3 y power half. Okay, now when we integrate with respect to the y-axis, we must write this one x in terms of y. Okay, so we will do the integration, and this time round we will have to put dy. Okay, we find out and we will get the answer as 5/7 over 9. Okay, just bear in mind, if you are integrating with respect to the x-axis, this is y equals to something x. If you're integrating according to the y-axis, it must be x equals to something y. Okay, if not, you'll be wrong. Alright, okay, now let's take a look at the second example. That is example 10. We move on to example 11. Now we are supposed to find the area of the shaded region P. Now a lot of you will say, oh, it's very easy. Y equals to ln x. I integrate ln x from 1 to 3. But the thing is that we do not know how to integrate ln x. Okay, there's no integration for ln x at this particular moment in your syllabus. Okay, now first of all, let's find the other way around. Now this equation is y equals to ln x. So y will be equals to ln x. If I write it in terms of index form, x will be equals to ey. That means this particular equation is x equals to ey. I have written x in terms of y. Now, can you see that the region here, Q, is the area between the curve and the y-axis. And when x is 3, this is ln 3. When x is 3, the y value is ln 3. Now, how do I get this value? I just need to take this rectangle here minus this area of Q. I will get the area of P. Now, let's find out area of Q. I integrate from 0 to ln 3. Then I take this particular one, EY, dy. I integrate, I'll get 2 units. That means this Q is 2 units. Alright? Now, area of P will be this rectangle, which is ln 3 times 3, length times breadth, okay, minus 2, which is 2 here. Then I will get the answer as 1.30 units squared. So we have to be careful. We cannot integrate ln x. So you cannot say, I want to integrate 1 to 3 ln x dx, because we do not know the answer for this. So we have to change it to the y-axis instead. So this is your example 11. Alright, next we go on to example 12, which is the last example in this particular section. Now, they want us to find the line PQ intersects the curve x equals to y square at the point R. Okay, find the area of the region bounded by the y-axis, okay, the line PQ, okay, and the curve x equals to y squared. That means they want this shaded region. Okay, first of all, I need to find the coordinates of R. Okay, in order to find the coordinates of R, I need to find the equation of PQ. Okay, and solve it with the x equals to y squared. So let's take a look here. Gradient of PQ. Okay, I use the gradient formula. I use the y-intercept. The y-intercept is 4, so I plug in. This is equation 1. This will be my equation 2. I solve the quadratic equation. I will get x4 and x16. Now, why is it that I rejected x16? Because R is before 8. So it cannot be 16. It can only be 4. Okay? Now, when x is 4, my y will be 2. Okay? So, the coordinates of R will be 4, 2. Alright? Now, how do I get the shaded region? Now, all of you look here. I'm integrating with respect to the y-axis. So I'll integrate from 0 to 2. Then y, in terms of y squared dy. Now plus this area here. This black area here. Now, be careful. This area here is actually a triangle. So half times base, which is 2 units, times height, which is 4 units. Okay, so I take this region plus the triangle. I will get the area that is required. I integrate, I add, I will get the answer. Okay, so this will complete example 12. Okay, now I just need you to take note of 2 things. Okay, to find the area of A as shown below here, okay, you are taking it with respect to y, you must write x in terms of y. So make x a subject before integration. That is, express x in terms of y first. Then you integrate the y expression here with dy, c to d. Okay, now another extra thing for you. What if the curve is on this side and you want the region B here, the area? Now, this is the same as the below the x-axis. This is on the other side of the y-axis. So the area of B is actually negative of integration c to d, this. Because if you integrate from c to d, this will give you a negative value. In order to make it positive, I got to put negative to make it positive. Alright, so take care of this. So let me just repeat. If you are integrating with respect to the x-axis, you must put y equals to x something something. Okay, if you are integrating with respect to the y-axis, you must put x in terms of y. Okay, I repeat one more time. If you are integrating with respect to the x-axis, it must be y in terms of x. If you are integrating with respect to the y-axis, it must be x in terms of y. If not, the answer will be wrong. Okay, now these are your homework questions. On the foolscap, these are the questions you are supposed to do. In your notebook, these are the 3 questions that you are supposed to do. Now, these 3 questions are quite good because they test you on your concepts of integration. Alright, so I will go through these 3. This will not be found in the video. I will go through these 3 on Monday, during the Monday lesson online. Alright, so take note of the questions and do them. Thank you.